Welcome to The Explainer. Today, we're going to unlock a really powerful tool for understanding our super complex world. And we're going to do it by tackling a question that seems simple, but as you'll see, has a surprisingly complicated answer.
So let's just start with something that, feels like it should have a very straightforward yes or no answer.
I mean, we've all wondered this, right? You're dragging in the morning, you grab a coffee. Does it actually work? Well, when you go looking for an answer, things start to get a little bit messy.
Because you'll see headlines that are completely contradictory. One study says, yes, caffeine is amazing. Another one comes out and says, nope, it's terrible for your focus. It creates this mystery. So who's right?
Well, the problem, of course, is that the real world is rarely that simple. Phenomena almost always have multiple factors working together all at the same time. And that's why a simple yes or no can be so misleading.
So to cut through all that confusion and really investigate these messy, multivariable problems, researchers have a specific framework they use. So let's dive into what's called a factorial design.
It sounds kind of technical, but it's really just a way to study multiple questions at once. It's designed specifically to test how different factors might work together to produce an effect.
Okay, let's get the jargon out of the way real quick. In an experiment, the things we change or manipulate are called factors. You'll also hear them called independent variables. Now, each factor can have different levels, which are just the different conditions. The most common setup you're going to see is what's called a 2x2 design.
So a 2x2 design means we have two factors and each of them has two levels. So in this example, our first factor is caffeine, and its two levels are caffeine and no caffeine. Simple enough. Our second factor is time of day, and its levels are morning and evening. When you multiply them together, 2 times 2, you get 4 unique experimental conditions that we can test. Now, the very first thing a factorial design lets us do is see the simple story. It lets us see what researchers call a main effect. It's kind of like the headline news.
In other words, a main effect answers the big, simple question. On average, does this one factor make a difference all by itself? We find that out by just averaging across all the conditions of the other factors.
And we do that by looking at the averages, what are called marginal means. So for caffeine, if you look at the average reaction time, it's 260 milliseconds versus 310 without it. So there it is, a main effect. On average, caffeine helps. And we can do the same for time of day. On average, people are faster in the morning.
And here's where it gets cool. If we plot this data out on a line graph, you see a really clear visual pattern emerge. The lines are parallel. This is the visual signature that tells you there's no complex story here. It's just two simple effects happening at the same time. But here's the big question. Is that on average story really the whole story? Well, a lot of the time it's incomplete, and it can even be totally misleading. So let's move on to the real story, the twist in the plot that reveals all the complexity. And this is what we call an interaction. It really all boils down to this one simple, powerful idea. The effect of one thing isn't always constant. It often changes based on some other factor. This is the key. The secret password for an interaction is the phrase, "it depends." So when someone asks, "Does caffeine help?" If the answer is, "Well, it depends on whether you're sleep deprived," boom, you've just described an interaction. And check this out. This chart illustrates the point perfectly. In this new study, we're looking at caffeine and sleep deprivation. And notice the lines? They are absolutely not parallel. They actually cross. This is that unmistakable visual signature, that aha moment that tells you there's an interaction going on. So let's boil it all down to a simple rule of thumb. If you see parallel lines, it means no interaction. The effect of one thing is pretty much the same no matter what. But if you see non-parallel lines, whether they're crossing or just spreading apart, that's your signal. You've got an interaction. The effect changes. Now, you might be thinking, okay, cool graphs, but why should I care? Well, this isn't just some dusty tool for scientists. It's actually a mental model for all of us to better understand the world. For starters, these designs let us test much more nuanced theories about how different factors might work together. They also help us find the boundary conditions, when something works and, just as importantly, when it doesn't. And all of this creates findings that are way more true to life, because let's face it, the real world is just full of interacting factors. So if there's one thing to take away from all this, it's this. Always look for the interaction. The main effects, those simple, on-average stories, they're just a beginning. The interaction, that's usually the real, much more fascinating story. It's where the simple answers fall apart and the deeper truths start to emerge.
So, I'll leave you with a question. The next time you hear a simple claim, a simple truth, ask yourself, does this really work for everyone in every single situation? Or does it depend?